watermelon. Now I am going to eat you. I am going to eat half of you, and then half of you, and then half of you, until... So, am I going to finish you or not? I don't know. Hi, Mama. I have a question. If I eat half of the cookie today, and eat half tomorrow, and eat half of the half the day after, when will I be able to finish it? You know what? You will never be able to finish it. No? You see, now I finish it. Okay, let me teach you something new today.
等比数列就是如果一个数列从第二项起，每一项与它的前一项的比等于同一个常数的话，这个数列就称为等比数列。这个常数叫做等比数列的公比，常用字母 Q 来表示。那么它的通项公式就是 an 等于 a1 乘以 q 取 n 减1次方。接下来我们来看一下它的求和公式。求和公式就是 Sn 等于1减去 q 分之 a1 减 an 乘 q， 也可以说是1减 q 分之 a1 乘以 a 减 n 去 n 次方，当 q 不等于1的时候。为什么呢？因为当 q 等于1的时候，它的分母就等于0啦。接下来我们来看看这个无穷递减等比数列各项和公式。当公比的 q 的绝对值小于1的时候 ，n 无限增大时的极限叫做这个无穷等比数列各项的和。接下来我们来看看等比数列在生活中哪里能看到呢？银行有一种支付利息的方式叫复利，那么复利就是按照复利来计算本利和，本利和等于本金乘以1加上利润乘以存期。好的，今天我们等比数列的课堂就教到这了，谢谢大家。Hi, welcome to math class. Today we are going to learn geometry series. What's geometry series? Geometry series is something like 0.5 plus 0.05 plus 0.005 plus etc., which is the sum of the terms of the geometry sequence. Okay, so let's see. In a geometry series, each term is equal to the previous term multiplied by a constant. The ratio of the term to the previous one is called common ratio. Okay, so let's see what is the equation of that. If R is the common ratio and A equal to A1, which is the first term of the sequence, then the formula for the nth term is AN equal to A multiplied by R to the n to 1 n minus 1 power. Okay, so let's see if we know how to find the nth term, how about how to find the sum? So for the geometry series, there is a expressive formula for the sum. So Sn will equal to the sum of from initial in 1 to n, a multiplied r to the power of I minus 1, which will be a multiplied by 1 minus r to the nth power over 1 minus r. Remember, the geometry series converges only if the absolute value of r, which is common ratio, is less than 1, not even equal to 1. And if the series converges, the sum will equal to a over 1 minus r, which is much easier than the other one. Okay. So let's see. In our first example, we give you is 0.5 plus 0.05 plus 0.005. The common ratio will be R equal to 0.5. No, R is equal to 0.1. Yes, because 0.5 plus multiplied by 0.1 will be 0.05. Okay, and which is less than 1, we can see. So the series converge, and we can get the sum 0.5 over 1 minus 0.1 equal to 5 over 9, which is sum of the series. Okay, let's see an example here. What is the sum of 5 over 2 plus 5 over 4 plus 5 over 8 plus 5 over 16 plus etc. So there are 5 choices: A, 2, B, 75 over 16, C, 305 over 64, D, 5. E, the sequence diverge. So take out your pen and think about it. Let's see, we can use the formula of this one since it converge. A over 1 minus R. Are you ready for answer? Yes, this is a geometric series with A equal to 5 over 2. We can see A is the first term, which is 5 over 2 over here. And then R will be 1/2. So it converges because 1/2 is less than 1. So the sum will be 5 over 2 over 1 minus 1/2, which is equal to 5. So we can see the answer will be D. Now let's do some free response questions. Determine if the following theory converge or diverge. If it converge, find its value. So let's see, we need to find 1 over n squared plus 3n plus 2 from n equal to 0 to n equal to infinity. Okay, so when we see this kind of function, we can see it's hard to just add it and just count it by our mind. So we need to try to do it into 2 easier functions, which is we need to do the partial function. So this is the original function, and then we need to write it into this kind of function, which is just factoring into algebra 2. Okay, so let's do a over I plus 2 equal to b over I plus 1. Now we need to find a and b. So from these two functions, we can easily see 1 will equal to a multiply the sum of x plus 1, which is I plus 1, plus b multiply x plus 2. So now we can see if x equal to -2, we just plug into this question. This one will be 0, and then to this one we will get -a will be 1. So a will be -1. So in the other end, let's do this one. Let's put x equal to -1 to this function. So when x equal to -1, this one will be 0, and then this one we will get b over b equal to 1. So that is basically how it is, how we find a and b. So we just plug in -1 and 1. So we can see 1 over I plus 1 minus 1 over I plus 2. This is the partial function we can find. Now that's easier. So since we got the partial function from this one, we can just try to write it out. So 1 plus I plus 1. When I equal to 0, this one will be 1 over 1. Minus 1 over I plus 2, which in this case, when I equal to 0, will be 1 over 2. And then we just write it out. And here we can get the final one will be 1 over n plus 1 minus 1 over n plus 2. Now we need to just do the cancel out. So this one and this one, we can cancel out because minus plus and minus plus, we can just cancel out all this. And then we can get 1 minus 1 over n plus 2 will be the final one we get. Okay, now just one more step. So what we need to do is, so basically from the sum is kind of from the limit of n to the infinity. So let's write it this way. And then we can just find 1 minus 1 over n plus 2. So when n gets bigger, and this number will become very small, so which we can just put it as 0. So 1 minus 0 will be 1. And 1 is the answer of the whole question. Remember to write out this function. Thank you for taking this math class about geometry series. Now the class is end. You can have a great summer.